What is your vision of the future? A bright and happy world of comfort and meaningful progress? Or a dark and dysfunctional world where you're trying to outlive the next catastrophe? Well, the bad news is, the way we're going, our chances of survival are not looking good. The good news is, by applying the developing science of climate restoration, along with all the other tools at our disposal, it seems increasingly possible to return our climate to how it was over 100 years ago.
Climate restoration is the goal and associated actions for restoring CO2 levels that humans have actually survived long term.
Climate restoration makes a whole lot of sense. It's win-win, healthier ecosystems, a healthier environment. A better planet is obviously better for us.
But it's never been just about the science. It's also about our behavior, our choices, and our will to change to survive. For many people, there's a vast chasm between what they hope the future will be compared to what they think the future will be, what they believe to be inevitable. And this is only reinforced by every other blockbuster movie, which is a disaster movie.
It's hard for me to be excited about the future, and I think I've realized a lot in my life that if people are still getting Instagram followers and can still get 2-day delivery from Amazon, they're okay, they're happy.
Today, the science and a little common sense is telling us that if we continue on our current path, even if we reach a point where the amount of CO2 we put into the air is balanced out by nature's process of absorbing it, known as net zero, we're still in for major problems. So where we stand right now, we being all life on Earth, is at the edge of a precipice, a tipping point that may be irreversible without immediate intervention. The Paris Accord, the new US Inflation Reduction Act, are positive steps working towards achieving net zero by 2050, but it's not nearly enough.
See, the elephant in the room is the carbon dioxide that we already have in the atmosphere. You see what's going on around us. You see all these extreme weather events, people suffering all over the world from floods, from droughts, from heat waves. This is all due to the CO2 in the atmosphere that we already have. And this CO2 in the atmosphere is not going away anywhere by itself. It's going to stay there. So if we stop emissions right now, this very moment, the series of extreme weather events will continue. That's the new norm.
So I developed the field of climate restoration out of my work in poverty and hunger. And I had set a mission statement for myself to leave a world that we're proud of for our children. And we made a lot of progress. And by 2010, however, all the progress in hunger and poverty was plateauing because of the climate. And so I realized that in order to achieve my mission, I had to make sure that we restored the climate and restored a sustainable population.
To understand how we may be able to solve the climate crisis, you also need to understand how bad things really are. And to do that, we have to go back around 800,000 years. Some of the most important climate data ever recorded took place in 1998. With a joint Russian and US team who took ice core samples to assess climate changes. The data taken from the East Antarctic ice shelf only goes back 800,000 years, because that's the extent of the ice pack. At 4 kilometers deep, it's the deepest known ice pack on the planet. What the data showed was a repeating cycle of approximately 100,000 years where the climate went from warming to cooling. As CO2 naturally increased in the atmosphere, climates warmed, and then as CO2 was naturally absorbed, the temperature cooled. If you look at the last 12,000 years, you'll see a time of climate stability, where CO2 was around 270 parts per million, and this is what allowed humanity to flourish. Apart from the occasional catastrophic volcanic blast, earthquake, tsunami or flood, life on planet Earth was pretty good, climatically speaking. But then, around 1760, came the Industrial Revolution. Powered by fossil fuel, leading to the fastest increase in CO2 levels in the planet's history. Today we're at around 423 parts per million of CO2, and since temperature records have been annually recorded, the average temperature has risen close to a critical 1.5 degrees of warming. This is a positive story, but it's not a story about hope. Nietzsche wrote that hope is the worst of all evils because it prolongs the torments of man. This story is about confidence around humanity's ability to solve a problem, whether it's a virus like COVID or the rising temperature of our planet. So, as the debate rages around how to save the climate, or indeed if it's even possible, scientists and innovators are busy exploring a range of ways to stabilize and restore the climate. The methods that present the greatest promise revolve around accelerating ways that nature uses to remove or convert CO2 and methane. Every year, winds pick up across the Sahara Desert and blow iron-rich sand across the Atlantic as far away as the Amazon basin. Along the journey, millions of tons of this sand drops into the ocean, fertilizing the barren central ocean areas, creating phytoplanktons and zooplanktons that capture enormous amounts of CO2 before being eaten or dying and sinking to the bottom of the ocean.
We can farm these algae to make very extensive fields of algae, and these fields would then absorb huge amounts of carbon dioxide.
There is major research being done at the moment on ocean iron fertilization to replicate the process at a global scale that could remove gigatons of CO2 from the atmosphere. Around 99% of Earth's carbon is permanently stored in the form of limestone. Limestone is Earth's stable CO2 warehouse. There's a wide range of new technologies designed to remove CO2 from the atmosphere, from Climeworks in Iceland to Blue Planet, a company in California that's developed a process of capturing CO2 at ambient temperatures and creating artificial limestone, a high-quality rock that can be used as an aggregate in the construction industry.
We can take any form of carbon dioxide and we can transform it into carbonate at any concentration because we're not trying to purify it into CO2. So that's one of the primary fundamental differences in what we do. We call it geomimetic because we're mimicking a geologic process.
Sargassum and kelp, seaweeds that are effective carbon sinks, are being harvested and converted into materials that replace fossil fuel products. Research is also being done on baling the seaweed and depositing them in deep, sparsely inhabited ocean areas.
The state of the climate is very concerning. It's hard to see, it's hard to be here in the Caribbean, but it feels really good to be working on something that we believe is truly scalable and can really move the needle in terms of climate and carbon sequestration.
Around 1/3 of climate warming is due to methane. Methane removal is essential if we're to reduce and stabilize global temperatures. Nature continually oxidizes methane in the atmosphere, breaking this superpotent greenhouse gas down into water and CO2. Scientists are now working to replicate the process in an accelerated way, referred to as enhanced atmospheric methane oxidation. One goal is to double the rate of oxidation to return methane to pre-industrial levels by 2028.
When we looked at how to find the best solutions, we realized that there were just 3 criteria required. That a viable solution has to be permanent. If the carbon isn't sequestered for at least 100 years, it's not a viable solution. It needs to be scalable to pretty much the level we need, which is 60 gigatons per year. And it needs to be financially viable because it's one thing to have a good idea, but if no one's going to pay you to scale it up to 60 gigatons a year, it's simply not going to happen.
The Titanic didn't see the impact of the iceberg coming until it was too late and wasn't able to steer from it. But in our case, the ever-growing impact of climate change is predictable and inevitable if we don't accelerate the research on removing CO2 from the atmosphere. However, an issue that's eclipsing CO2 is the ever-growing threat of a methane burst. It's happened before, and the consequences would be disastrous.
Here we are, we're in a tsunami zone. We are routinely preparing for a worst-case disaster scenario here in Port Townsend. We have no preparation for a worst-case scenario of a methane burst.
Methane now is in everybody's gun sights because as the Climate and Clean Air Coalition to reduce short-lived climate pollutants has calculated, the effort to reduce methane can avoid nearly 0.3 degrees Celsius of future warming by the 2040s. So it's now the single biggest and fastest way to slow future warming in the near term.
One of the top scientists working in the field of methane and methane removal is Dr. Renaud Richter.
So methane is a greenhouse gas, much more powerful than carbon dioxide. On 20-year basis, it's 86 times more powerful. And what is attracting in methane is its short lifetime, because it's only between 8 and 12 years lifetime. So we can act on methane, and we should act on methane, because right now the global warming due to methane is 0.5 degrees Celsius, and the carbon dioxide is only about 0.8. So methane is really the second most important greenhouse gas, and acting on it, we can reduce temperatures.
Methane comes from a wide variety of anthropogenic, human-caused sources, as well as natural sources. Human sources are different sections of agriculture, different leaks from gas and oil systems, and also different types of waste, landfills, wastewater, etc. We've also always had some natural emissions from things like wetlands and termites. But the overall methane emissions have dramatically increased due to human-caused activities, both human-driven sources of methane, as well as now climate changes that are accelerating some of those natural sources.
We've got feedback loops that are happening right now in the atmosphere that are essentially creating a runaway feedback loop of methane levels rising. Simultaneously, 40% of all methane that ends up in the atmosphere is coming from so-called natural sources, such as this wetland behind me. Unfortunately, both the 60% coming from man-made sources and the 40% coming from natural sources are increasing. And the fear is that that 40%, the natural sources, that we may have triggered a feedback loop that could exceed the 60% now that we see coming from man-made sources of methane, and we could get a sudden burst of methane in the atmosphere, which would be, simply put, catastrophic.
So this feedback loop, where the warming climate is causing more natural methane to be released, which in turn is also contributing to temperature rise, is no more apparent than in Siberia and Alaska, where the consequences can be seen growing by the day.
So this path that I'm on used to be boreal forest with spruce trees, birch. Beneath me and under the ground, there are massive blocks of ice. We call them ice wedges. And those blocks are melting. And because of that melt, it's turning into a mucky puddle. In the next year or two, this puddle is going to become a pond that is really the birth of a new thermokarst lake. It will grow bigger and bigger, and this environment can produce a lot of methane gas. I'm pretty concerned because this is my only way so far to get to my study site. So perhaps instead of walking, I'll be taking a boat in the future.
The Arctic Circle region has been heating up for the past 20 years at roughly 4 times the rate of the average for the whole planet, which means that today the Arctic Circle is at 3 degrees above the pre-industrial level, and therefore the Arctic Circle tipping points have now irreversibly tipped without interventions. Now what does this mean? And I think it's important that I spell this out. What happens in the Arctic Circle impinges on the entire world and is already doing that. The extreme weather events we're experiencing around the world today are heavily driven by what's happening in the Arctic Circle region.
Compared to the 1981 to 2000 average, the March Arctic sea ice pack had lost about 1 million square kilometers.
When permafrost ground is frozen, it contains massive amounts of carbon, 1,500 billion tons. That's 150 years worth of current human fossil fuel emissions, all frozen in the ground. And it's frozen in the forms of dead plant and animal remains. So when the permafrost warms and thaws, it's like opening a freezer door and giving microbes a huge feast. All that carbon that's been frozen for thousands of years becomes food for microbes that decompose it. And when it's under waterlogged conditions, like the bottom of a lake, oxygen cannot get into the sediments, and so the microbes make methane. Methane is about 30 times stronger as a greenhouse gas than carbon dioxide. So there's a big concern, a big implication for permafrost thawing and forming thermokarst lakes.
What we are seeing is a disaster in the making. If all of that methane was emitted, let's say over a 20-year period, global temperatures will rise by 5 to 8 degrees centigrade. And when would that happen? It has already begun to happen on a smaller scale. My fear and our fear is that in a few years' time, because this heating of the Arctic Circle region is still continuing, this may release rather quickly.
Right now, we're chasing a fast problem with slow solutions. Indeed, we're chasing an accelerating problem with slow solutions. So slow success is no success. We need to find ways to speed up climate mitigation. We need to focus more on adaptation and resilience. And then ultimately, we need to find a way to restore the climate to its past safe and stable state.
So what are the options available to reduce and remove methane from the atmosphere in quantities that will make a meaningful difference to the climate?
Plan A is always to mitigate overall climate change in order to mitigate those emissions in the first place. But at this point, we need a plan B as well. And that plan B is starting to understand if there might be ways that we can help to remove that methane from the atmosphere more quickly than it naturally would break down on its own.
But amongst the profound challenges that methane presents to the climate are some real opportunities due to its short lifespan of up to 12 years, as opposed to the hundreds of thousands of years that CO2 takes to naturally break down.
The reason that methane is so short-lived in the atmosphere is that it has a number of ways that it naturally breaks down, and that happens in the air and that also happens in soils.
For some reason, humanity seems cursed to find the simplest of solutions to be the hardest to implement. And one simple way to address global warming is by protecting wetlands like this one in Washington state that provides a wide range of important benefits, not least as a method of CO2 and methane removal.
Wetlands are important for so many reasons. Wetlands provide vital ecosystem services that benefit people. Wetlands filter water and improve water quality by removing pollutants. Wetlands provide water storage. So places like Barney Lake, which is the area around me, can store an immense quantity of water during high water events, which helps prevent flooding elsewhere in the watershed. Wetlands can help recharge aquifers where people get drinking water. And wetlands can help store CO2 and methane by drawing it down from the atmosphere and storing it within the wetland itself. Climate change and land use pressures are degrading wetlands and accelerating the loss of CO2 and methane into the atmosphere. Because methane is produced in places like the sediment underlaying the water you see in wetlands where oxygen is scarce, disturbance of wetlands can accelerate the loss of CO2 and methane into the atmosphere. This compounds the fact that climate change in general accelerates the release of methane and CO2 into the atmosphere. So the processes that impact our wetlands are helping to transition some of our best carbon sinks to carbon sources.
We need big structural changes, yes, to reach 2050 climate neutrality, but we cannot wait for 2050. We have to cut emissions fast. And methane is one of the gases we can cut fastest.
To date, 312 countries have signed on to the Methane Pledge, in which they commit to working together collectively to reduce global Anthropocene methane emissions across all sectors by at least 30% below 2020 levels by 2030. This is a huge step in the right direction, if the succession of ever-changing governments are able to maintain their commitment.
I think one of the main barriers is there's no price on methane. Companies and people don't pay anything for the methane we release into the air. An oil and gas well that leaks gas into the air is free. So we need to change that and put a price on methane in the same way that we need a price here in the United States on carbon dioxide pollution. As long as greenhouse gas pollution is free for companies, there's no incentive, no financial incentive for them to act.
One of the not-so-natural ways of removing methane is a method used extensively by the oil and gas industries: flaring, where excess methane is burnt rather than storing it or releasing it directly into the atmosphere. Throughout the world, there are disused oil wells and mines that continue to leak methane long after they've closed down. Frost Methane, a climate restoration startup, is addressing these leaks through the development of a compact flaring system that can be installed, operated, and monitored in remote locations.
So my name is Oli Razak, and I run an organization called Frost Methane Labs, and we find concentrated, continuous, unregulated sources of methane and install devices to mitigate them. Ever since I started working on it, methane has always felt like it was underinvested in. And so even back when I was at Google, I tried starting a methane project, and then when I left and saw that there were these exploding hills in Siberia that were being discovered recently, that's when, I really started this project. So methane is 28 times more heat trapping than CO2 over a 100-year time frame, kind of including its half-life, decomposition in the atmosphere. And just burning it is basically the cheapest mitigation you can imagine, because it turns one molecule of methane to one molecule of CO2, and it's extremely low cost, and it is reasonably, compared to some of the other solutions, it is reasonably easy to do in a very robust way. I think how cheaply we can mitigate this really, really matters, and so I've always been focused on finding the lowest cost solutions, and this really kind of hit the sweet spot. So we take methane that otherwise would have made it out into the atmosphere, right? So it's coming through cracks in the ground, it's coming through lakes, it's coming through old water wells. So this is methane that is not economical for oil and gas companies to capture. If it is, fantastic, right? Putting it in the pipeline is always better than setting it on fire without a productive use, but often it's not possible, right? Because the pipeline is too far, the quantities are too small. And so what we do is we build these devices that set it on fire, but the methane that's coming out from our sources is pretty different than what's coming out of your stove. I mean, it's still methane, but it's methane that comes with nitrogen and CO2 and sulfur. It's not coming out pure, and it's coming sometimes at variable flow rates. So one day it could be coming out quite a bit, and another day maybe a lot less. So our device needs to be able to handle the variety of flow rates and the variety of gas compositions that come out naturally.
A lot of methane is coming out of these lakes, and the way that it's coming out is by bubbling. That's important because there are other microbes that can eat methane, and that would be a good thing, but the bubbles move so quickly up through the water column that other microbes don't have time to eat the bubbles. Those bubbles come to the surface of the lake and they pop, and they're putting 80–90% methane that was in the bubble straight into our atmosphere. And once that methane molecule enters the atmosphere, It just takes 1 year for it to circulate around the whole planet. So methane coming out of the Arctic spreads around the entire world and contributes to global climate warming. Yeah, this is a homemade methane bubble trap. It's got a plastic bottle, a tube, a stopcock, and then a plastic skirt with a ring around it. And bubbles that are leaving the lake sediments rise up and they go into this trap and they get funneled into the bottle. Methane is natural gas, so it's flammable, and we collect samples and bring it back to the laboratory to measure the exact concentration. But very often when we're in the field, we can do a flame test just to make sure that the gas we have is methane. So I am going to push the bottle underwater to pressurize the gas, and then we'll light a match. And if it's methane in here, the flame coming out of the stopcock should get bigger. If it's not methane, then the fire on the match will go out. We've got methane. And it's such pure methane that it's actually burning but clear.
Back in northern Alaska, Frost Methane is exploring whether the technology they're using to flare escaping gas from mines can be modified to capture and flare methane being released from lakes. Major amounts of methane are being released into the atmosphere from the decomposition of vegetation due to thawing, but there are also more dramatic methane releases being seen, possibly caused by fractures in the ground that are releasing fossil methane gas, the type of methane that's extracted by oil and gas companies.
If you look at a map of the Arctic, you'll see that there are millions of lakes. All the lakes emit methane, but most of the lakes emit a lower level of methane. It's these new lakes, these lakes that have formed recently from permafrost thaw, that are emitting the highest amounts of methane. And that is because the freezer door has recently been opened. So the microbes are having their feast. These lakes are the key to understanding the future. Models suggest that the majority of surface permafrost in the Arctic will be strongly thawed by 2100. What models do not take into account is the formation of these lakes. And when these lakes form, the water heats the ground and thaws at orders of magnitude faster. We get deep, fast, abrupt thaw. And so the carbon that's very old, deep beneath these lakes, becomes food to microbes that are generating methane that's bubbling out of the lakes. And the impact is that it will double the permafrost carbon feedback. So what scientists had thought before for emissions from permafrost carbon on land will be at least 2 times higher because of the formation of these lakes and their potent methane emissions.
Greenland, sitting in the Arctic blue sea now during those 3 summer months, is losing its ice irreversibly, and when all of it is gone, 6.5 meters to 7 meters sea level rise. And also, now this is important, permafrost on the land mass around the Arctic Ocean, the North Pole being roughly in the middle of the Arctic Ocean, permafrost is now losing methane explosively, particularly in Siberia.
We don't focus on the scary outcome of a methane burst, in large part because the science is uncertain. But if I knew there was a 1% chance of a catastrophe happening, and we were not prepared for that 1% chance, although we could have been, you know, again, this is what we weigh in terms of what is the moral, what is the ethical thing to do. To be prepared for a worst case disaster scenario, absolutely.
One thing I'm excited about now and that we work on a lot is looking for technologies and ways to remove methane from the atmosphere and also from dilute sources that are emitted from human activities.
So people know this treaty because it's put the stratospheric ozone layer on the path to recovery by 2065. And that's prevented skin cancer, cataracts, reduced immune systems in humans and animals. Hugely successful. Every country of the world is a party. Every country of the world has been largely in compliance, and as a result, that treaty has phased out nearly 100 damaging chemicals by nearly 100%. And because those same chemicals are climate-forcing chemicals as well as ozone depleting, the Montreal Protocol has done more to solve climate change than any other agreement.
Another major greenhouse gas is methane, which is far more potent than CO2 and also forms a significant part of the scientific move towards CO2 removal and restoring our climate.
One thing about methane is that it's always being emitted and you can't stop it. So this is a project where we want to remove the methane because it is so dangerous to human life. And then we need to continue working on that indefinitely because it's going to continue to be emitted at greater levels than it was before humans industrialized. Well, let's talk about the ocean. The ocean covers 3/4 of the surface of our planet. At the top of the ocean, there's the waves flick up and make a little spray. They also put up chlorine atoms. And that chlorine, plus natural other chemicals that occur at the top of the ocean, NOx's and such, breaks down the methane. It shatters the molecule, I guess is the best way to think of that. So this is what nature has been doing for, I don't know, millions of years. It's just not sufficient to keep up with what we're doing to the atmosphere. So French scientists figured out a second aspect of this, which is you may know that the wind picks up dust. For example, it picks up the dust from the Sahara, blows it across the Atlantic, and that fertilizes the Amazon. In fact, it's the iron in that dust that fertilizes the Amazon. Well, it turns out that iron acts as what's called a catalyst. It helps to speed up this ocean-going reaction. What we are working on is sending these iron chlorides over the ocean, just in the air about 20 meters up. We're starting with a small, what we call a smog chamber. What we're building there is a kind of a test jig. Okay, it allows us to experiment with some chemistry. It allows us to experiment with some detection work and do it in a well-controlled environment so that we can control the variables and say what happens if this one moves or what happens if that one moves. Now that is not what happens in the atmosphere, but standing on that, we can build a much larger test system that we can experiment now and on do these things that work in isolation now work as a system.
And then that information will give us what we need to talk to regulators, build environmental impact assessment so that we can do very small tests outdoors, knowing what the worst cases can be.
So what we're doing with Blue Dot Change is, you'll hear much more about this, but essentially replicating and amplifying the natural iron aerosol methane cracking. Methane has one carbon, a bunch of hydrogens around it, and so we're cracking it in the sense of taking the molecule apart. And it's a natural process that is in the open is operated by iron and various other, it's a long complicated chemical story, but the iron through various chemistries pulls apart the methane, and that's essentially what we're doing. And so we have several different layers of this. Eventually we'll do it in the open ocean after we validate that the process works and we know we can control it and we know that it's safe. Well, the reaction we're looking for, if you were to just do it once, is relatively inefficient. And so you have to do what's essentially simulate what's called a catalytic reaction, where the materials are used over and over again to crack many methane molecules. Again, I'm using cracking slightly wrong, but it's evocative.
What we are working on is sending these iron chlorides over the ocean, just in the air about 20 meters up. And the way we want to do that is by working with ships. And so the idea is to spray this catalyst into the plume that comes out of the ship. You know, that's up 20 meters above the water, can travel for hundreds of miles. Since it's a catalyst, it can keep breaking down methane as it goes until the rain washes it into the ocean. Basically, we're helping nature do what she already wants to do, but just do more of it to compensate what all of us are doing when we heat our homes or otherwise use methane.
Well, I think the moral hazard argument, as we call it, is important. You don't want companies to be able to say, well, I'll emit my pollution today because someone in the future will be able to remove it from the atmosphere. We want to keep those gases out of the atmosphere right now. But nonetheless, if rapid methane release from the Arctic happens, or some other unexpected increase happen, for instance, in tropical wetlands, we don't have a technology right now for dealing with those increases. And I think methane removal as a potential technology gives us that opportunity. It's an insurance policy to run away methane release, or a lack of human action, frankly.
I spent about 3 months listening to the scientists, listening to the legal minds that had weighed in on this, and I came to the conclusion that this is such an extraordinary opportunity to essentially, potentially shave peak temperatures by anywhere between 0.4 degrees Celsius and 1 degrees Celsius over the coming decades. That this could be the technological breakthrough that we need. But if we can both cut methane emissions, as the global community has come to recognize we need to do rapidly, and simultaneously scale up the science around methane removal through research and development and putting in place very thorough governance mechanisms to make sure it is not misused, that this could be a way to begin the process of achieving the goal that I think all of us want, but we're afraid is out of reach, namely climate restoration, returning to the climate that our grandparents lived in. My biggest concern was around moral hazard. This is something that I think those of us who have been fighting the fossil fuel industry for decades have come to understand that the industry is, that nothing is beneath the industry, whether it's denial, deception, buying off politicians, despite the consequences. And so I could foresee the possibility of a technological sort of equivalent of get out of jail free card for the fossil fuel industry if this technology was scaled up in such a way that did not have absolute prohibition against it being used in that way. While we, on the one hand, are weighing this moral hazard and looking it square in the eye and doing everything possible to eliminate it, we're also recognizing that future generations are certainly going to evaluate the steps that we take now at this critical juncture. And if we were to tell them, oh, we were afraid of shaving peak temperatures by 1 degree Celsius because, you know, we were afraid that that this would be an immoral act. I can imagine my grandchild or my great-grandchild just laughing at me and saying, no, of course you should have done that. You should have done all you could to give us the environment that you inherited.
There is a position that if you repair the climate, then you're just taking the pressure off people to behave better. That's a lovely utopian vision. I would like to believe it myself, but I know that I live in the real world. And the fact is that if somebody builds a building today, it's going to be standing for 40 years, heating itself the way it was built. If you put a ship in the water, it's going to be transporting cargo for at least 25 years. So while people are struggling to work on new solutions to cause these things to pollute less, let's use the effort, the pollution that they are doing to fund this very important thing of reducing the amount of temperature rise. I would love it if there was no value in doing this. That's actually where I want to be. But you know, I do live in the real world, and today there is value in it. And let's use that value to fund the work of making the planet a better planet for everyone.
Okay, my last.
We have an enormous amount of work to do. We, as humanity, have an enormous amount of work to do. And what caused me when I had that conversation with Peter, when I was getting this, when I had that conversation with Peter, I felt hope. Maybe we could do something. And I dropped all my other work, which was interesting work, to say, I really need to work on this because I am well suited from my background to work on this very project. And I wish to keep breathing for 20 years. I'm just being pretty frank about that. And what's been gratifying when I do talk to other people about what we're doing is people saying, wow, we feel hope. We didn't know it might be possible to repair the climate.
Well, we spend most of our time trying to stop methane emissions today. I work in homes looking at appliances like stoves, furnaces, and water heaters. And stoves, for instance, not just release methane and greenhouse gases into the atmosphere, they release indoor air pollutants like NOx gases and hydrocarbons that we breathe that triggers asthma and other diseases. So I want everyone to think of climate solutions not just as helping the environment, but improving our health. My group also works on methane emissions from oil and gas wells and transportation and all kinds of other sectors. So we're trying to find that methane and use aircraft and satellites and mobile measurement systems to put pressure on companies and help them identify leaks and squish them or squash them.
We need to reduce our emissions by 50% by 2030. That's only 8 years away. That's 8 harvests. That is students who are currently starting middle school. They're going to be going to college. And so the time frame is so short, and the lack of concrete action has been minimal around the world. And we keep seeing crises that really set us back, such as the Russian invasion of Ukraine.
Every ton of greenhouse gas we emit from today will have to be removed together with all the excess greenhouse gases we've put up there already. We are currently at well over 500 parts per million if we count in not just carbon dioxide, 420, but also methane. The pre-industrial level was 270 parts per million. So we have already closed in on doubling the amount of greenhouse gases. We cannot foresee a manageable future for humanity without deep and rapid emissions reduction and greenhouse gas removal at scale. I believe we need to reduce from 500, 550 parts per million to roughly 350 parts per million to achieve a manageable future for humanity.
The world as we know it is changing. Yesterday's impossible is today's headlines, and everyone is affected. And yet we spend so much time making and watching disaster movies, we don't realize that each and every one of us is in a disaster movie. But this isn't a story about disaster. It's about a way out for all of us. Today, there are new solutions being developed that, working together with existing technologies and realistic policies, can return our climate to levels last seen over 200 years ago. Climate restoration is the biggest thing we're not talking about, and together with ecosystem restoration offers us a way back from the edge.
Climate restoration means getting the climate back to levels that humans have actually survived long term. And the value of that's pretty clear, I think. The net zero just means not making it any worse.
Climate restoration makes a whole lot of sense, first of all, because it's win-win, healthier ecosystems, a healthier environment, thriving forests. A better planet is obviously better for us and all other living things. And so it's a no-brainer to try to restore our environment as much as we can.
Many of the solutions for restoration, help us on the way to stabilizing and slowing down the feedbacks and avoiding the tipping points today. So it's a question of how far do you keep going?
Yeah, so when decision makers make a goal, we always assume that they have a good reason for that goal. Now, probably everyone knows that climate is very complicated. Everyone says, well, I'm not the ultimate expert in climate. And so no one has taken responsibility for, is this the good goal or not?
We're at about 420 parts per million right now. Now others like Peter Furkowski say, if we can go back to 350, let's keep going, because pre-industrial levels were about 280 parts per million. Let's go back, let's keep going, make the climate even safer and more resilient. Now, how do you do that? Well, there are brilliant strategies, and I usually describe this as a series of races. So you have to win the sprint to 2030 by cutting the superpollutants and stopping near-term warming, slowing down the feedbacks, and avoiding as many of the tipping points as you can. That's essential. You have to win that sprint. Then you have to win the marathon to 2050, which is the shift from fossil fuels to clean energy. Maybe we can do it even faster than 2050, but 2050 is the target most countries have set. Then you have to win the ultra marathon, which is taking CO2 and methane out of the atmosphere faster than the natural cycle. That's climate restoration. And that can be done. We know the physics, we know the chemistry. Now we need to put our technological genius to work and figure out how to do it at scale, at speed, and at some reasonable cost. But what's a reasonable cost when you're talking about saving the planet? I mean, we need to put trillions into our climate solutions, not billions, but trillions.
Goals are essential, but to achieve them, we need to develop a shared vision of what the world could look like if we all work together restoring the climate. Culturally, the narratives need to move away from disaster fantasy to stories of a world where things could go right. Practically, we all need a clear understanding of what the choices are.
Fundamentally, the Earth's carbon sinks are now being completely overwhelmed by our human numbers, our appetites, our mindsets, our voracious predatory economy, and we no longer can rely on Earth's natural systems to take care of our mindless waste. Therefore, we need to, I think, embrace climate restoration fast and using nature-based approaches so that technology is balanced by a fundamental mind shift to a regenerative economy, regenerative society, regenerative livelihoods, and a completely new regenerative civilization.
What if climate change isn't real and we blindly follow science, rush requirements to turn industries green? The economy would hurt, we'd all lower in net worth. Retirement funds and nest eggs for your children would lose value round an earth that starts to breathe again, where weather's less extreme again. Humanity could stand a chance to stick around past like 2085. Your family would survive, cause what's the point in keeping nest eggs when the nest is getting fried? What if climate change is real, but we don't prioritize and trust the science? The heat's rising and 2090 could be the end of this. Think about that risk. Cause if we move too slowly, kids alive today just can't grow old on this planet.
Around 95% of CO2 contributing to climate warming is the CO2 that's accumulated since the start of the Industrial Revolution. In terms of removing CO2 from the atmosphere, there are two distinct methods: CDR, carbon dioxide removal, and CCS, carbon capture and sequestration. CDR is the process of removing CO2 that's already in the air and permanently storing it, reducing the amount of CO2 in the atmosphere. CCS is the process of removing CO2 from a system that's producing CO2 as a byproduct, for example an oil refinery or a cement factory. The only way that we can return our climate to levels that will avert the ever-growing catastrophes and where all life can thrive is by applying carbon dioxide removal together with all the other methods.
Right now, we're chasing a fast problem with slow solutions. Indeed, we're chasing an accelerating problem with slow solutions. So slow success is no success.
It was like a nickel dropped, and I got that we can do it. It's like the moonshot.
The facts of the matter are that we have never made the national decisions or marshaled the national resources required for such leadership. I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the earth.
What I have found in my work is that if you can't convince people to do something because it's the right thing to do, you can often convince them because it is the financial reason. And the more that we move towards commodifying our waste and finding secondary markets for those products, those things, then we're going to find more and more ways to sell those in communities. And the reality is, especially rural communities have been bearing the brunt of so much of this. They're where we site all of our energy facilities. They're the ones who are growing our food. And so when you get a very partisan approach and you try to apply it across the board without really getting their input, it kind of falls flat. So the more we're monetizing both our waste management stream, whether we're talking about recycling wind turbine blades or the cradle to grave resource ethics around batteries, we've got a lot of room, I think, to create an economy of the future that incorporates that waste stream management into what we're doing.
The world population has more than doubled since 1970 to its current level of over 8 billion. And as societies have developed, much of the planet's life expectancy has continued to increase. Infinite growth with dwindling finite resources is not sustainable. So population and consumption has to be a part of the equation in balancing the climate and our resources. It's been written that the meek shall inherit the earth, and that may be so, but it's not looking like a very good deal. The earth we're leaving behind to our children and future generations is growing less habitable as each year progresses. The youth that are fortunate enough to receive an education know enough to feel angry and frustrated that their voices are being drowned out by powerful organizations and lobbyists. Protests are an essential aspect of any struggle to be heard and affect change. But as a member of the public, where else can you go if you feel powerless, depressed even, and want to be a part of positive change?
I think one of the things that drives me to do this work, in addition to having been compelled to do environmental work throughout my life, is seeing some of the hopelessness that the youth have shown through their climate assemblies. They're really incredulous that we haven't done more already and that we've let it get to this point, that we do it under the auspices of preserving the economy rather than realizing that the planet that we live on is the only way we're all going to survive. Trying to find ways to help build up hopefulness among young people, to show that the innovations that we have the ability to create, the collaboration and the ability for governments and for non-governmental organizations and nonprofits to come together to have a unified tapestry of responses.
I mean, if we really took a look at our younger generations and what they're actually telling us, how can we possibly say, no, we're just going to leave the planet the way it is, we're not going to do anything about it? No, it really is up to us. I also do believe that as adults and older generations, we have a lot of wisdom and things that we've seen work in the past that we can actually share with the youth. So I think it's important for both parties to collaborate together in that way.
My role in the villa.
Youth groups like this one meeting in Egypt on the fringes of COP27 were learning about climate and ecosystem restoration and how they can be encouraged and adopted within their own communities.
We are always talking about a future that we may have a chance to live normal life and survive in, but what we need is safety, and no one is talking about a real safe future for us. When I got first into the climate restoration, I was like, wait, don't we know it already? Why is it something new? How is it possible that people didn't talk about this before? It's so weird, in my opinion.
So what else do you do when no matter how loud you shout, your voice isn't being heard? Or you're being belittled for sounding angry? Will the protesters of CO2 reduction join the cause of climate restoration? Is this what it takes to effect change? Some of the other approaches being pursued to safeguard our future include organizations like F4CR, working with communities to provide climate education for youth and to influence policy at local levels.
So we're off to a fundraiser. It's back at my house, and it's for the people that we've worked with for many years, some of them, and for a few years, some of them, who are interested in restoring the climate, restoring a climate that humans have actually survived.
For as long as I've been aware of the climate crisis, the main focus has been on doing the least bad, or maybe avoiding the worst consequences. So I don't think any of you would be here if you thought that was good enough.
I think I'm not alone, having had this like storm cloud of eco-anxiety over my head, you know, especially as a younger person, feeling like what I have to do is just live my life with my head down and hope for the best. Surely someone will figure out how to fix this problem. So why I'm here is because that is my future, that is my son's future, and there is work to be done. And I've found, as I think many people have, that nothing kills eco-anxiety like being in action and dedicating yourself and your resources to the work that you think is most critical.
Across the world, people suffering the most from climate change are usually the people with the least say. So as we map out a path forward, as either scientists, innovators, policymakers, or activists, we have to be inclusive. Intelligence is no substitute for wisdom and experience.
Well-meaning people come in with, we have all of the answers. Instead of really leaning into the work and saying, I need to first understand the problem I'm trying to solve, which is empathizing, meaningful consultation, gathering those facts, and then not assume that I know the answer and allow the problem to be defined by the community inhabitants, and then to have a collaborative partnership on how we reach the solution.
Wandering around the halls of COP27 in Sharm el-Sheikh, Egypt, the daily presentations and media frenzies gave the sense of high energy and hope. But COP27 was generally considered to be an inadequate response to the climate emergencies we're now facing. Although progress was made on the Loss and Damage Fund, which aims to provide assistance to nations most vulnerable to the effects of climate change, many saw COP27 as a regression from the gains made at COP26 in Glasgow. But the lag of real progress in fossil fuel reductions only emphasizes the urgency of researching, developing, and implementing additional technologies around carbon and methane removal. We know that over the last 800,000 years, the climate has ebbed and flowed massively in cycles of around 100,000 years. And yet since the last ice age, the past 11,000 years have been a time of relative climate stability, allowing everything in our civilization, agriculture, art, economies, cities, to develop and flourish. But with the advent of the Industrial Revolution starting around 250 years ago, the dramatic increase of fossil fuel gases released into the atmosphere, along with the destruction of forests and natural habitats, has led to an accelerated warming of the atmosphere at a scale never before experienced in the known history of the planet. But we've always had the ability to avert the climate disaster we're now in. All we had to do was less of what we were doing. But we didn't. We did more and more until we got to where we are now. So it's all about our thinking, our behavior, and our choices. So here we are, out of road and out of time, but not out of ideas or science or resources to restore a world that has been so badly damaged by our inventiveness and insatiable appetite for more. Climate restoration is offering us new, tangible possibilities, and we should accept nothing less than what our children and the planet deserve, a way back to our future.